So hello everyone, I am Varun Kumar, and in this video I will design a G+1 building in ETABS. So it is the interface of ETABS, and I have already made some models. So now click new models, model initialization. So initial setting of your models, which type of code you will use for designing your structures. So I will use bold in settings. Okay, and display units metric SI, and region for default materials India, steel sections database Indians, and steel design codes IS 800 2007 for steel concrete steel design, and concrete design IS 456 2007. It is okay, then click OK. So now new model quick templates. So I will design a structure, and first I will draw my 2D layout and hand tree layout for decided the location of grid. So in I have a plot and it is rectangle. Okay, and because it is a 100 by what, it is 10 into 3 equal to 300 into 300 feet square area. Okay, but now I will consider 10 meter by 10 meter equivalent 100 meter square. So this distance is 10 meters from her to her, and there are one more 10 meter. I will design. So first I will decide where is my bedroom and where is my kitchen and where is my veranda, where is my washroom and where is my staircase. So there are, this is opening. Okay, and I will divide in this section in 4. This is 5 meter and this is 5 meter, and there is one room and dimension is 4 meter by this dimension is 4 meter, and it will be 4 meter. Okay, और ये क्या है हमारा बेडरूम, one bedroom, and second is there are some opening and there are another bedroom. It will be 4 meter by 4 meter, and it is my entry, and the door of this bedroom is her, and the door of this bedroom is her. It will be open area, and we can parking any vehicles, small vehicle like cycles and bicycles and bikes, etc. So it is my entry door, and we can create guest house. Okay, and the area of guest house is nearest 5. This dimension is 5 meter. It will be 5 meter, and it will be 4 meter. 4 meter. So according to this, so my first grid line is, and second grid line after 4 meter. Okay, 4 meter. This distance is 4 meter, and it is 1 meter and it is 1 meter. So second grid line will be after 2 meter, and after this it will be 4 meter. And now there are one more grid line for this purpose. Okay, so there are one more grid line, and the distance will be from this distance to this distance is 1 meter. Okay, it will be in center. So I have 4 grid line in the direction of x, because this direction is x. So x direction में there are 4 grid line. नहीं, total is 5 grid line. First, second, third, fourth, 5. So spacing will be, first is 4 meter, and second after 4 meter, 1 meter, 1 meter, and 4 meter. So go to ETABS. Now click grid dimension, go to custom grid spacing, go to edit. Now select display grid data as a spacing. So my first spacing is 4 meter, and second spacing is 1 meter, third spacing is 1 meter, and fourth spacing is 4 meter. Okay, in the direction of x grid data. Now we are going for y grid direction, y grid data. So there are one grid line and second grid line and third and then 4. So we can make a kitchen. Okay, we can make a kitchen, and after in the next it is a ground floor. Okay, it is a ground floor, and we can make, there are bathrooms, any washroom, guest room on the second floor. Okay, and we can establish, first we will add one more grid line, but it is not necessary for, so I will not count this grid line, because the height of this wall and thickness of this wall is very less. So we will consider the all dead load of this portion, because it is a kitchen and it's depend on you that कि आप ओपन किचन बनाना चाहते हो या फिर क्लोजली, मतलब इसमें वॉल लगाना चाहते हो, इट इज डिपेंड्स ऑन यू. ओके, एंड first grid line, second grid line, third grid line, and fourth grid line. It is 4 meter, and it is 4 meter, and it is 2 meter. Four meter, 2 meter, and then 4 meter, and I will delete this grid line. So it will be 4 meter. Okay, 4 meter, 2 meter, it will not update now. Y direction, 1 2 3 4 meter, 2 meter, 2 meter. Okay, it will not count it. I will modify it. There are some glitch. 4 5 1 6, total is 6 meter. 0 4 5 and then 6, but it will not 6. Go to display, there are 4 4 and it will be 0, but not 0. A B C D. Okay, so add one grid more and there are 4 meter. Okay, and add one grid more and there are 4 meter. Okay, it will be fine. Then click OK and click OK. So there are some mistakes because the total story is 1 2 3 and 4. So I will edit the story of my structure. Go to edit and go to edit stories and grid system. modify story data. So I will delete the above story. Click right and then click delete story and click delete existing story. Click right and click delete and click delete story and click right and click. There are a total of base, story 3 and story 4. So the name of this story is ground level GL, and second is floor 1. Okay, and the height of the base will be 0 and height of ground floor is will be 1.2 meter and total height is 4.2 meter. Okay, and there are no master stories. Click OK and grid system will be same. Now click OK. So it is a 3D view of my grid system. Now first, because the height of my buildings is not much high, so the column dimensions depend on the height of buildings and depend on the weight of buildings. Okay, and we will use the thumb rules of columns and beams, and first we will define the properties of materials, but there are first is ground floor and second is first floor. So G+1. Okay, it is first floor and it is ground floor. ठीक है. Now go to define material properties. I have M30 grade and Fe 345, but it is very much strength, so I will use the grade of concrete M20. We can use M20 and M15 for design of beams and columns. In the case of 2 stories and 3 stories and only 1 stories building. Okay, so click OK. So material properties data. So M20 grades. Okay, and I will. It's depend on you that key I can write 25 for good calculation, for good understanding. Okay, material nodes, time depend, it is not necessary, and modulus of elasticity, it will be same, and material damping properties not necessarily modify, so material properties design. Okay, material properties M20 character cube strength is 20. Okay, it will be 20, but I will write there are 25. Why? The weight per unit volume is 25. Okay, 25, because their material properties damping will be 0. M25, it will be 25, and then M20 grade and unit weight kilonewton per meter cube is 25 for concretes, and user specify, click OK. M20. Now add for rebars. So we will use rebars for HYST grade 5. Okay, Indian standard code, add. So there are unit weight, modify material properties 500, 545, 550. It is okay, we can change, but it's not necessary. Now click OK. But I will delete all properties, other properties, because there are no option for deleting the above properties, so cancel it. Now I will define the sections properties. So frame sections. Now add new properties. Concrete rectangles. Concretes. So I will use 250 by 250, 250 by 250 column sections. Okay, modify. So because I will use this section for columns. Okay, so the four columns. If I will apply earthquake loads, okay, in the but my building height is very less. Okay, so it is not necessary. But in the case of, because I want to replicate my model for 2 stories and 3 stories, so I will add it. So the moment of inertia about 2 to axis will be 0.7 in the case of columns, and it will be 0.7 in the case of columns. Okay, mass participation is 1 and weight will be 1. The torsional constant I will not consider it. Okay, but I can use. Okay, now it is a column, and properties of longitudinal bar and confinement bar will be HYST 500 rectangular. Other properties, reinforcement to be designed. This option is right for me because I will design, and I will, in the case of design, I will select the reinforcement, which type of reinforcement, how many reinforcement, and the dia of the bars. What will be the dia of the bars of my columns? I will select after in the case of design. Okay, then click OK. So sections properties, it is okay. Include automatically rigid, not, it is not necessary. Modify name of material. Material will be M20, and the properties is column 250 by 250. Okay, click OK. Now select these all properties and delete it. Delete multiple properties. So I will select these properties and these properties, delete selected frame, and now delete these properties, delete selected frame. They are column 25, and now click OK. Now click add, click concrete rectangles, and material will be M20, and this is my beam BEM, एंड बीम की डायमेंशन कितनी होगी? बीम की डायमेंशन होगी 200 बाय 300. ओके, 200 by 300. Depth will be 300 and width will be 200. Modification factor for moment of inertia will be 0.35, 0.35, and it will be 0.35. Mass will be 1. Okay, other factor is 1. In the case of column, torsional constant, we can use torsional constant for 0.25 because torsional capacity of the columns will be less. Okay, 0.25 in the case of torsional, but I will not consider in my column because my building height is because I am not designing a tall buildings. Okay, depth will be this one, and modification servers. I will design beam and HYST 500, HYST 500. Top bars cover will be 25 top and 25 bottom. Then click OK. So now click OK. Okay, so because there are, if I will rotate it, so you can you can see matlab it is my it is my ground floor, it is my first floor, so I need to add one story more for G+1 building. So edit, go to stories, modify stories, and click right, and click add story. Keep existing story height 3 meter. Number of add stories 1. Insert above f1 f1. Okay, now click ok. So they are 7.2 meter height. Total height will be 7.5 meter. Height will be 3 meter and 3 meter. Then click ok. Okay, now click ok. So it is now it is okay. So go to edit and go to edit story and grid system, modify stories, and this story, my first story will be master story. Okay, yes, master story, but it is not a master story, no, and it will be similar to f1. Okay, and it is the RWF roof. Okay, there are rough. Now click ok. So go to plan view and go to first floor plan view, apply, and okay. So now I will design columns and beam. So because in the case of structure engineer, okay, like that, जैसे कि आप staircase बना रहे हो या गेस्ट रूम, या फिर वो गेस्ट रूम बना रहे हो, वॉशरूम बना रहे हो, या बाथरूम बना रहे हो, या किचन बना रहे हो. इन द केस ऑफ किचन यू कैन यूज एनी secondary beam, you can use any secondary beam, but in the case of मतलब कि in the case of tall building you need to design all members, but in the case of small building like that 2 floor 3 floor या 1 floor, so it is not necessary that कि आप हर जगह पे कॉलम लगाओ, because the area of total area will be 100 वो 10 meter by 10 meter equal to 100 meter squares. So in the case of 100 meter squares, if you will design, there are many columns. First column, there are one column, there are two column, there are three column, and the distance between columns will be 2 meter, 1 meter, 1.5 meter. It is not good for designs, because मेटेरियल की कॉस्ट भी ज्यादा हो जाएगी, एंड ऊपर से कि वो कोड के अनुसार इतनी कम स्पेसिंग में आप कॉलम नहीं बना सकते. Okay, so the distance between column will be nearest 4 meter, 3 meter, 2.5 meter, not less than 2.5 meter. In the case of 2.5 less than 2.5 meter, you can go tall buildings, and tall building in the case of tube sections. So if you are design any columns in tube sections, so you can use the distance between columns will be less than 2 meters. But in the case of any structure building, the distance between columns 2 meter will be not sufficient and not good according to me and according to codes. So now we will delete it, and my beam height. Okay, so there are some. Okay, so there are one supports and there are second supports, and total height will be total is 4 meters. Okay, ठीक है. So according to this 4 meter, so dimension beam width will be, so to divide it 4 meter 4000 divided by 10 equivalent 400 mm, otherwise 4000 divided by 12 equivalent 36 and कुछ कितने 400 nearest 3.33 mm, but I will take 300. Okay, but I have take 300. So I will check that ki 300 will okay or not for my beam depth. Okay, so now go to modeling. So first select quick draw beams and columns. So for in the case of quick draw beam and columns, type of lines is frame. Okay, and my column is column 200, 250 by 250. Okay, and movement releases will be continuous. Okay, so it will design beam. First I will design column. Okay, so go to these options, quick draw columns, and select column. Now click it, and second my second column is her. The spacing between this column and this column is 2 meter. Okay, I can take it. And second is her, and third is her, and fourth is here, and third is here, fourth is here, five is fourth, fifth, sixth. I can not use there, and third is okay. Understand the concept of this column layout. Go to exclude, click extrude frame, and then apply, and then OK. Now shift and click rotation. So the spacing slow. Go to plan view, go to first floor plan, and then apply, then OK. Yeah, okay. The spacing of between two columns is very high. Why? Because there are one door. Okay, and if in the case of door, so you can make a column in the in the side of the in the side of the doors, because if you are designing a column in this sides, okay, and if you are designing a column in this sides, and you are designing a column in this, and you are making a column here, so the in this wall, okay, in this wall, ओके इस वॉल में आप क्या मतलब कि आपका जो ये वाला डोर रहेगा यहाँ पे सही से अटैच नहीं रहेगा, सो डोर विल नॉट बी अटैच. I will tell you in the figure. First delete it. So it is my plot, and there are door. Okay, and door spacing will be nearest 2 meter. Okay, 1 meter this side and 1 meter this side. So if I will not make any column in this side, so I will make first column in this side and in this side. The column spacing will be center in the inner sides will be 2 meter, because my door size is 2 meter. Okay, so इट्स डिपेंड ऑन कि बिकॉज कि आपको डोर कितना लगाना है, एंड आपको डोर बाद में डिजाइन करना है, पहले कॉलम्स बनाने हैं। ओके, इफ यू विल डिजाइन कॉलम्स एंड इफ यू मेल योर स्ट्रक्चर्स एंड आफ्टर यू विल डिसाइड कि आपको डोर किस डायमेंशन का बनाना है, तो वो शायद ज्यादा ओके रहता है, बिकॉज क्योंकि कॉलम्स की जो स्ट्रेंथ है वो अच्छे से मिल जाती है, क्योंकि गेट के साथ, एक्चुअली डोर के साथ आपको यदि कॉलम बनाने हो तो कॉलम का जो जो उसका फर्मा होती है, शटरिंग होती है, वो आप ओके से अच्छे से नहीं कर सकते। ओके, तो शटरिंग प्रॉब्लम होती है, बिकॉज आपका ये डोर है एंड आपने पहले डोर लगाया एंड डोर के बाद यहाँ पे आपने इसको यहाँ से हुक किया हुआ है एंड यहाँ से आपने इसको हुक किया हुआ है एंड आपको इसके हुक के साथ ही यहाँ पे कॉलम डिजाइन करना है इस तरह से। सो इन दिस केस आपका क्या होगा कि मतलब आप इसमें हुक जो आप डिजाइन कर रहे हो, बट यहाँ पे आप सही से मतलब शटरिंग नहीं कर पाओगे, तो द सरफेस ऑफ कॉलम एंड कॉर्नर विल बी नॉट एक्यूरेट एंड द देयर आर स्ट्रेंथ, मतलब स्ट्रेंथ उतनी अच्छी नहीं रहेगी, स्ट्रेंथ डिक्रीज हो जाएगी एंड होमोजेनिटी नहीं रह पाएगी कंक्रीट में। तो काफी सारी चीजें, काफी प्रॉब्लम्स देखनी पड़ती है, अनसर्टेनिटीज बहुत ज्यादा हो जाएंगे। सो फर्स्ट यू विल डिजाइन योर स्ट्रक्चर्स, यू विल डिजाइन योर स्ट्रक्चर एंड आफ्टर you will decide where are you will add any doors and any walls। okay, because but if you know that कि आपको यहाँ पे डोर लगाना है, तो आपको यहाँ पे डोर लगाना है, बट आप पहले कॉलम बनाओगे, कॉलम के बाद डिसाइड करोगे कॉलम का साइज कितना है। आप मतलब नॉर्मल रख सकते हो, जैसे कि ये 2 मीटर, मैंने मान लिया कि मेरे को 2 मीटर का डोर चाहिए, बट ये 2 मीटर से, बिकॉज डायमेंशन विल बी 250 एंड 250। ओके, सो 250 मतलब ये 2 मीटर में से 250 माइनस हो जाएगा, मतलब कि ये बाद में बचेगा 1.75 मीटर। ये आपकी डोर की डायमेंशंस रहेंगी एंड इसमें भी आपका हुक टू हुक रहेगा, हुक टू हुक यहाँ से लेके यहाँ तक फुल। ओके, एंड इट इज नियरेस्ट आएगा 1.7 मीटर जो आपका डोर आएगा। तो यहाँ पे ये मतलब यहाँ पे कॉलम लगाना ज्यादा सही रहेगा एज कम्पेयर टू यहाँ पे, क्योंकि हमारा एक कॉलम यहाँ पे है, तो हम यहाँ पे कॉलम ना लगा के इस कॉलम को यहाँ पे लगाएंगे। ठीक है, एंड सेकंड क्या है, स्टेयरकेस। जैसे कि आपका एक स्टेयरकेस यहाँ से जा रहा है, आपने डोर के फ्रंट से स्टेयरकेस लिया हुआ है। ओके, एंड स्टेयरकेस क्या है, ये इधर से तुम्हारा ऊपर की ओर चढ़ के आएगा। ओके, एंड देयर आर स्टेयरकेस एंड देयर आर लैंडिंग। ओके, 2 मीटर की लैंडिंग है, 1 मीटर इधर है, 1 मीटर इधर है, एंड आफ्टर दिस इट विल अटैच टू द दिस पोर्शन। सो यहाँ पे आपको एक स्लैब चाहिएगी, एक्चुअली यहाँ पे आपकी एक स्लैब है ये, एंड यहाँ पे आपका स्टेयरकेस जा रहा है, यहाँ से आप ऊपर की ओर जा रहे हो, यहाँ पे आप ऊपर पहुंच जाओगे, तो यहाँ पे आपको एक कॉलम्स ऐड करना होगा। ओके, अकॉर्डिंग टू योर स्टेयरकेस, बिकॉज इट विल हेल्प इन द सपोर्ट्स ऑफ दिस कॉलम्स, दिस बीम, बिकॉज यहाँ पे आपको एक बीम बनानी होगी। ओके, एंड उस बीम को ये सपोर्ट देगा, एंड इस बीम को आप, हो सकता है कि आपको इधर कनेक्ट कर सकते हो, अदरवाइज यदि आपकी स्ट्रक्चर विदाउट दिस कॉलम सेफ आ रहा है, यदि आपकी स्ट्रक्चर विदाउट दिस कॉलम सेफ है, सो इट इज नॉट इम्पोर्टेंट फॉर। ओके, तो ये कोई जरूरी नहीं कि आपको बनानी है, बट आप तब बना सकते हो जब स्ट्रक्चर आपकी मतलब सेफ नहीं, मतलब कि आपकी कॉलम्स की स्ट्रेंथ कम हो रही है, तो आपको एक एडिशनल कॉलम्स यहाँ पे ऐड करना होगा इन दैट केस। ओके, बिकॉज यू ऑलवेज यूज मैसेनरी स्ट्रक्चर्स, और एंड मैसेनरी स्ट्रक्चर्स की खुद की एक स्ट्रेंथ होती है, कंप्रेसिव स्ट्रेंथ होती है, तो वो बेयर कर लेती है इतना लोड। ओके, their spacing will be nearest 4 to 6 meter। okay, it is very large spacing, so first I will make a column। so there are, because actually इसमें मैंने ग्रिड लाइन नहीं बनाई है, बिकॉज यहाँ पे कोई ग्रिड लाइन नहीं है, तो इस केस में मैं क्या करूंगा, इस केस में मेरे को कुछ नहीं करना है, मेरे को यहाँ पे एक जॉइंट बनाना होगा। ओके, एक जॉइंट मेरे को यहाँ पे बनाना है, नियरेस्ट 2 मीटर की डिस्टेंस पे। ओके, अदरवाइज मैं इसको ऑफसेट कर सकता हूँ, यदि मेरे को जॉइंट भी नहीं बनाना, मैं ऑफसेट कर सकता हूँ। जैसे कि ये डायरेक्शन कौन सी है, एक्स डायरेक्शन, दिस डायरेक्शन इज एक्स, Okay, and there are plan offsets. Extraction will be minus 2000. Okay, and then I will click her and it will make a columns in this side. Okay, so I can use offset for make this column. And second is I need one more columns her, because this distance is 5 meter, and I will count first. My staircase is actually it is enough for this distance 4 meters or not. So go to, so my building height is h is 3000 mm. Okay, and if I will use landing is 180, and rise is this one, and rise and trade दोनों कितना हो गया, 250. 250 is nearest 10 inch. Okay, 250, 180, 250. Otherwise 170, it's depend on you, because for good staircase you can use is dearest 280, and 300 is good because it is equivalent 10 inch. एंड और जो एक नॉर्मल ह्यूमन के पैर की साइज होती है वो नियरेस्ट 3 इंच के आस, वो 7 इंच, अदरवाइज 7, 8, 9, नियरेस्ट 9, 10 इंच होती है. सो इट इज ओके फॉर नॉर्मल बिल्डिंग. द साइज ऑफ दिस इट विल गुड. ओके, बट इन द केस ऑफ hospitals and college buildings, in the case of college building you can use 300 by 150, मतलब कि 150, 300, 150 rise trade and 300. Okay, rise your 300 and trade is 300, so it will be 250 and it will be 180. 250. Okay, and my total building height is 300, so I will divide 300 to 180. It is equivalent 16. Okay, 16 rise. Now 16 multiply by minus 1 equal to 15, and then multiply by 250 equal to 3916 meter, nearest 4 meter. So we can make, and now it is okay. So I will use, it is 1800, I will change it. Okay, I will use 150. I will use 150. If I will use 150 divided by 150 equivalent 20 there, and minus 1 equal to multiply by 250, 475. It is okay because there are 1 meter and there are 6 meter. I have 3 meter and 3 meter for make staircase. Okay, so I will use one more column here for support, because the spacing between these two columns is very much very large, so I will use offset will be 0, and there are offset, other offset will be 2 meter, 2 minus 2 1 2 3. Okay, now use okay. I have designed. Now I will design columns and I will design beams. Now I will design beams. So click this option and select beams and drag it, and there are one beam, and there are second beam, third beam, there are four beam, there are five beam, six beam, and seven beam. Okay, it will be okay, 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 and okay, and there are, because I will use quick design beam for this option, but for these beams I will use these options. Okay, now click there, click her, and click her. Okay, click her and select the beam size is 200 by 300. Now click her and then click her. Okay, right click and click her and click her. Right click, click her, click her. Right click, click her, click her. Right click and right click, click her, right click. Okay, so there are full area, it is a open area because there are no beam and there are no column, because I have staircase in this side. Okay, I have staircase in this side. Okay, and I have landing in this sides, and this area will be open fully, and we cannot create any columns inside this area because there are no rooms. Okay, because kitchen will be here. Okay, and we can make bathroom, we can make washroom there. Okay, we can make washroom, otherwise we can make any washroom in her, because it is 1 meter and 1 meter, there are total is 2 meter we can make. Okay, the door will be in this side and the door will be in this side, the door in this room will be in the outside. Okay, we can make a door in outside, because बाहर की साइड एक डोर बना सकते हैं यहाँ पे, और यहाँ पे हम एक, मतलब यहाँ पे विंडो एक्चुअली विंडो लगेगी, and there are one windows and one doors, and there are one windows in this side and there are one doors. Okay, and it is area for kitchens, this area for kitchens. Okay, and it is full space, and we can use any open area for sunset. We can create any opening for light के लिए, for lighting. Okay, go to 3D view, to the 3D view of my structure. Okay, now there are, because What happened? Go to plan view, go to first floor view, go to apply. There are no beam. Okay, but beam will be here always. So click this option and click beam option and then click here and then click here. Okay, press yes. Now it is okay. Go to define, go to section property, go to slab section and slab 1, modify slab. The grade of concrete is 20 grade and national thickness of slab will be 120 150 mm slab thickness. Properties same, modify. So in the case of slabs, in the case of earthquake, we can use 0.25 0.25 and 0.25. Okay, properties stiffness modification factor for slab. In the case of slab, we can use 0.25 0.25 0.25 0.25 for all. Okay, but I will check it first. तो स्टीफनेस मॉडिफिकेशन फैक्टर फॉर बैंडिंग. ओके, देखो हम बीम में मॉडिफिकेशन फैक्टर 0.35 क्यों यूज करते हैं. हम 0.25 0.35 इसलिए यूज करते हैं बिकॉज उसमें बैंडिंग होती है एंड बैंडिंग के कारण क्रैक आने के चांस ज्यादा होते हैं. बट इन द केस ऑफ कॉलम्स, कॉलम्स में एक्सेल लोड लगता है, जो एक्सेल लोड जो है उसके अंदर होने वाले क्रैक को कम करता है. यदि तुम कॉलम में यदि पॉइंट लोड लगा रहे हो, लेटरल लोड लगा रहे हो, तो लेटरल लोड में बिकॉज उस पर एक्सियल लोड भी लगा हुआ है जो उसको सपोर्ट करता है थोड़ा लेटरल लोड को रेजिस्ट करने के लिए. सो इसलिए उसमें जो स्टीफनेस मॉडिफिकेशन फैक्टर है उसके लिए हम 0.7 लेके चलते हैं कॉलम में एंड 0.35 बीम में बिकॉज वहां पे और कम है. बट इन द केस ऑफ स्लैब, स्लैब में बेंडिंग के चांस और भी ज्यादा होते हैं, तो बेंडिंग के चांस ज्यादा होते हैं एंड क्रैक आने के चांस भी ज्यादा होते हैं. तो इसलिए इसमें जो इसका बेंडिंग में जो मॉडिफिकेशन फैक्टर है उसको हम 0.25 लेके चलते हैं. वी विल कंसिडर 0.25. ओके, बेंडिंग 1 बेंडिंग 2 एंड बेंडिंग 1 it will be 0.25 and it will be 0.25 and it will be 0.25. Okay, हम we can consider for all पैरामीटर इन 0.25. इट डिपेंड ऑन यू बिकॉज कि आपको उसकी मतलब स्टीफनेस को रिड्यूस करना है या नहीं करना है. मतलब कि आप अपनी स्लैब को अपने हिसाब से डिजाइन करना चाह रहे हो कि आप उसको कितना मतलब एक्चुअली कितना स्ट्रेंथ उसकी कंसाइडर करोगे. हाउ मच स्ट्रेंथ यू विल कंसाइडर इन योर स्ट्रक्चर्स फॉर योर स्लैब्स. ओके, देन क्लिक ओके and now click OK. Now I will design slab. Go to quick draw slab, select slab 1, then click 1 and then click 2 and then click 3. But it is full one slab. Okay, it is a one slab and it is a two slab, fully two slab. Okay, we have two options. I can make all slab and I can merge. Okay, so I will merge. Okay, it is easy for me. I will make all slab. Okay, and now click ESC and then select this one. What happened? Please go to her. Okay, it is okay. So now select this one and this one and this one, this one, this one, this one. Go to, I have select this slab. Okay, ठीक है. And go to edit, go to edit cell, go to merge cell. So joints cell 1, then click OK. Now it is one slab. Now select this one, click this one, go to edit and go to edit cell, go to merge cell. No, cancel. I have select this option, but go to edit, go to cell, go to merge cell. Now click OK. So it is a one different slab. ठीक है. Go to 3D view. So it is my 3D view. Now click here and add new window and click here and go to then apply. Okay, so this is a structure view of my first floor. Okay, now I will assign the load on this floor and then I will replicate. It is first method, and second is I will replicate and then I will assign the loads. So I think it is good. So I will select all properties. Okay, now select all members and beams, columns, slabs. Now first I will create opening. Okay, I will create opening in this region. Okay, so draw wall opening, breadth mm, height nearest 1, bottom distance and left distance. Oh, breadth, height, bottom distance and left distance. बॉटम से कितना डिस्टेंस लेके चलना है, लेफ्ट से कितना लेके चलना है. ओके, I think there are some issue. Okay, I will make opening after. First I will replicate. Now select this one and then go to edit and go to replicate Now roof, it is a first floor, ground floor, first floor, roof floor, then apply, then okay, it will be fine. Okay, so and now I'll make the lower beam. Go to ground floor, apply, okay, define section properties, frame section, and add new sections, make concrete sections. It is 300 by 300. Modify so section properties is torsional constant, moment is 0.7 and it will be 0.7, then okay, and now click here, will be HYST column rectangular 40 reinforcement design. Okay, click grade of concrete is M20 and column 300 by 300. Click OK and click OK. Ready view. Now quick draw column. It will be 0. Okay. Click here. Then click here. Then click here. Then click here. First is here. There are and second is there extra action is -2 1 2 3. Okay. Now we will design the plinth beam. Define material section, frame section, add new properties, concrete beam 200 by 200, concrete grade M20 200 200, modify 0.35 and 0.35, click OK. Modification factor beam only, HYST cover will be 25 and then 25. Now OK. Yes, okay. Quick draw beam, select beam, 200 by 200. It is the plinth beam. Second, third, and then 4, 5, 6, 7, 8, 6, 7. We will make one beam here and we will make one beam here. Okay, and I will make one beam here. Go to this option. Okay, this model is okay, but I think there are no beam in this figure. I have beam in this floor, but go to upside. There are one beam. Similar, similar, similar. Beam. Yeah, okay, okay, okay. But there are no beam in this figure. There are. Acha, it is rotated. Now go to 3D view. Okay, it will be fine. Okay, it will be fine. Go to exclude option. Go to exclude cell. Then apply. Then okay. Now select all story and go to plan view. Go to first floor view. Then apply. And okay. Now I will assign the live load, dead load, and super dead load. Okay. So go to define. Okay, section property. First I will define diaphragm 1 and add 1. Second is diaphragm 2. Apply. Then okay. Now go to single story, one story, and then select this all joint. Okay, and otherwise erase. Select slab. Now assign joint diaphragm D1, and otherwise there are second option assign cell diaphragm D1. Apply. Okay. Now go to above side, select slab, and now assign cell, go to diaphragm, select diaphragm to design. Okay, go to 3D view, G1 and G2. There are two diaphragm, diaphragm 1 and diaphragm 2. Now I have assigned diaphragm, so go to say define diaphragm, peer level node, spandrel level, graphic diaphragm, section, strength, go to function response spectrum, select IRC 187 2016 and add new function. Zone will be 4, it will be 4 zone, and damping ratio damping will be considered 0.5%, importance factor 1, soil type 1, and response spectrum SRS method 5 1. Okay, convert to manual detail. You can convert float, log x, linear x. Okay, linear x and y direction. It is okay. Now click OK. Click this response spectrum. Click this. Now click OK. Go to define. I have defined response spectrum and generalized displacement. It is not necessary for mass source. So modify mass source. So elemental self weight not considered. Mass source a specific load pattern. So there are dead load, okay, and live load. So it I will consider after, but first I will define load pattern. Okay, load pattern. So I have dead load factor is 1 and live load factor is 0, and second is S ideal. S impose dead load. Impose dead load, it is dead load, and super dead load, it is super dead load factor will be 1. Now add it. Okay, we have dead load and live load. Click OK. Now go to define, go to mass source and modify mass source. Click specific load pattern, elemental self weight neglect, dead load factor will be 1. Second is live load factor will be 0.5. It is depend on you because I have only 2 story. Okay, story 1, story 2, ground and first floor. So I will consider 0.7. Okay, other, but according to my thing it will be 0.9. It will be 0.9. Live load will be 0.9. Okay, 0.9. First I need to delete this one, and now at live load is 0.9. What happened here? 0.9 add, and second is super dead load will be 1. फिर my goes here super dead load 1 add dead load 1, super dead load 1, and live load 0.9. Okay, include vertical mass. ठीक है, adjust it is not necessary. Click OK, then click OK. Now I will assign live load, dead load. First I will assign live load and dead load, and then I will assign weight load and seismic load. So first I will check the response of live load and dead load on my structures. So in the above structures, so go to plan view and go to first floor plan, apply. So there are wall. Okay, first wall there are 1 wall, 2 wall, 3 wall, 5 wall, 6 wall, 7 wall, 8 wall, 9 wall, 10 wall, 11 wall, 13, 14, 15, 16, 17, 18. So there are walls. Okay, now I will assign wall load on this frame. Okay, go to this option. Now select that one here. So wall density 20, wall density 20, okay, multiply by wall height is 3 meter, 3000 minus 300 divided by 100. It is the wall height. Okay, and wall thickness is 20 mm. 20 mm divided by 1000 and 1000. It will be, go to calculator, LCR 2.7 multiply by 20 and multiply by 0.2 equal to 10.8. It will be 10.8. Okay, now select it. No wall. Go to assign, go to frame load, go to uniformly distributed load, go to super dead load and apply 10.8. Apply. Okay, it will be okay. Now go to above floor, select this one, outer side. It will be half of this one. Not half. It will be 1/3. Half. No. It will be 1/3 nearest. I can count now. I can measure. Don't worry. I can find. It will be multiply by this vector, convert it to 100, and it will be 1000. So 20 into 0.7 into 0.1 equivalent 20 multiply by 0.7 multiply by 0.1 equal to 1.2. 1.2. Apply and okay. Go to 3D view. So it is fine. Now go to plan view, go to first floor, go to ground floor plan. Okay, and apply. Okay, select these beams, these all plinth beams. Go to assign, go to cell load, go to frame load, go to distributed load and super dead load. It will be 10.8. Okay, there are okay. It is okay. Now go to select these panels. It is selected. It is selected. Now assign cell load, uniform load. Go to super dead load 1.5. Okay, apply. And second is live load 2. I will take extra 0.5 dead load because live. No, it is okay because live load will be 2 point. Because in the case of SIDL load we can increase. In the case of if I want to make any structures like I want to check any something in the case of washroom, bathroom, kitchen. If I want to add any like any load, any machine load and other case, we can add any extra load in the SIDL load. Okay, if I want to make any wall, small wall, so I want to make any for 10 wall in this sides. Okay, I will make any. I want to change any something in this regions, so I can add extra super dead load on the your slab because in future कोई भी इंसान मतलब नॉर्मल घर में कुछ भी चेंज करा सकता है कि नहीं मेरे को अपना वॉशरूम बाथरूम इधर शिफ्ट करना है या किचन इधर शिफ्ट करना है इस तरह से करना है सो we can change the columns locations and beams locations but we can add extra loads in the case of any future if you want to change any small structures in your inside your buildings. Okay, so dial load will be 2. It is okay. Okay, now select previous selection, then assign okay. Okay, and I will add superimpose load will be SIDL load will be 2. Okay, replace to existing load. Now previous selection, now apply okay, close it. Go to above story, select this slab. SIDL will be there are no extra 0.75. Apply and live load will be 1. In this case I will use 1.5 kilonewton. Now previous case apply okay. So I have applied live load here and here. So go to 3D view. Okay, there are live load already mentioned. Go to define and function mass p delta option non-iterative based on mass. Automatic methods. Okay, and second is defined is load patterns. I have make load pattern. Now I will create EQ X, select seismic load cases I8 875 1893. Edit. Click Y. Edit. And go to. I will not add wind load because wind load calculation is much different. Modify load case. Go to zone will be 4 and it's 2 1 0.25. Uncheck this all things. Okay, now story, rough story, base story, bottom story, story range bottom to it is okay. Okay, and second is now I will consider from ground level to this one because yes, ground level to this one response spectrum. Go to OK. Now select this one, modify this one, check this all boxes. It will be 24. Now select ground level and now it is okay. Click OK. Go to define load pattern. Have done cell uniform load. It is not necessary for. Go to load case. There are dead load, linear static, modify. There are load pattern dead load 1 and mass sources M1. Near real static. Okay, it is okay. Mass source 1 and it is second mass source will be 1. MSSRC 1. Okay, it is okay. Now model. Go to modify. Model linear. Okay, it is linear. Eigenvalue this is okay, and then load pattern and second is acceleration. Go to extraction, maximum cycle 0, add seconds, acceleration in y direction. It will be 99 and it is okay. Maximum number of models is 12, minimum number of models will be 1. Okay, P delta analysis negatively based on the mass. Based on the mass. Okay, it is okay. It is okay. So click OK. Now SIDL linear static, modify according to mass sources, not attractive. ठीक है, ये भी it is okay. Now modify. Click earth peak, mass sources, earth peak in x direction, y direction. It is okay. Load pattern. Now close. It will be right. It will be okay. It will be okay. Now create new. Okay, linear static. It is the response spectrum, and there are models CQC and SRS. And now click add acceleration in U1 direction. Default. Go to response spectrum 1. Scale factor. I will add it after. And now create add 1. We can make add 1 response spectrum in this side and second. We can merge both one side. Default response spectrum. It is okay. I will scale after check the result of the behavior of structures. Okay, it is okay. Okay, 5% damping. Okay, all of diaphragm. Okay. Mass sources MSSR 1. Okay, default. Load case name is RS. It is okay. So now click right. So I have defined load case have done. Now click load combinations. Add default load combination according to concrete frame design and concrete slab design. Okay. Convert user defined Click now concrete and concrete slab. Concrete column frame, concrete slab. Now click OK. So define it have done auto constructor sequence. Okay, working it is slab name. Okay, right. Draw, select, assign, cell load, live load have done, but they are because this video is very because this time is for now sleeping. So there are I want to make staircase in the sides, and now I will assign the live load and dial load on the staircase. So I will because I will do it in the next day and any other times if I have time. But now I will check the result of these structures. Okay, now go to analysis, go to check model. I will select tolerance value nearest to her nearest 550 nearest 50. Each depend on you which type but and joints. I select all things and click joint story assignment. It is not necessary. Okay, right. Model has been checked. No warning message was generated. Okay, so my modeling will be my modeling has been done and it is okay. So go to analysis, go to set active degree of freedoms. So there are three multi degree of freedoms. Okay, it is okay. But now I need to create. Oof. Okay, go to plant view, plant base. Okay, okay. Select these all joint. Go to assign, go to joint, go to restraint, and select fixed beam. Apply. Then okay. It is okay. Now go to 3D. So they have done. Go to analysis, check model, and set load case. All loads has been run. Okay. Now click analysis. Go to advanced solver. It is okay. Multi-threaded solver. It is not. GUT process and separate process and applying process options. GUI process. It is auto is okay and advanced solver is standard solver. Advanced solver multi-threaded solver. I will use advanced solver and program determined 12 user specified. All things is okay. Analysis. Go to advanced design and response recovery options. Auto mesh section for floor. Okay, I need auto meshing. Generate mesh. Approximately maximum mesh size is 125 mm. Okay. Analysis. Auto mesh rectangular mesh section for walls. I haven't any walls. I have only floors. Okay, I am meshing floors. Analysis model for nonlinear hinge. It is not necessary for in these conditions and cracking analysis options. It is I will not consider model alive, manage analysis and go to run. Make new folder and write G+1 building. G+1. Okay, save it. So this model have done. So go to start. So it is animation behavior, and I have switch off the music, because if I want to start the music, you can start. There are no, but you can go to option and go to sound. But it is very close the sound. Now go to undeformed shape and go to dead load, apply. It is the go to plan view and first floor plan. Yeah, go to elevation view, and then assign elevation one side. Okay, you can see it is your elevation. The load, the bending moment in your plinth beam is very less. Okay, so it is the main reason because why we are not designing the plinth beam in the case of any building. Okay, because plinth beam having less bending moment shear force, it is able to resist this moment. Now case of earthquake load in x direction, apply this one, it is very less. Okay, and second is earthquake load in the case of response spectrum, the behavior is like this. Okay, bending moment on, it is very large in the case of SIDL. So go to close it. Now go to undeformed shape and go to result, go to display, go to show table and go to analysis result, go to structure output, go to base shear, table base shear, and now okay. Earthquake load is minus 87. Okay, in x direction, and y direction is minus 83. RS is 95.67 and it is 93.92 point something. So I need to decrease it. Okay, divided by this one, 87.459 divided by 95. 87.4529 divided by 95.6727 equal to 0.914. 0.914. First is 0.914 and second is 8 3.496 divided by 92.1094 equal to itna. Okay, so this value is for, it is for x and it is for, I have divided 92, I have divided 95. So this value for fx and this value for fy. Okay, go to define, go to load gauge and select response spectrum, modify it. Now click this one and multiple cancel it. Multiply by x will be 0.914. 0.914. Okay, and second is multiply by 0.906. 906. Let's see. Go to run. Go to display. Go to show table. Okay. 1893, 187. It is okay. Now done. Now go to design. This section will be failed. Go to 3D view. There are section 1, section 2 and section 3. First go to design again. Go to design, concrete frame design, view design preference step by step. Yes. Second is go to concrete design. Go to concrete frame design, view, review, select design group, select design combinations. There are column designs. Okay, and now go to start design check. We have done. Now go to display beam design, display design information. Total longitudinal reinforcement. Apply this beam. Share will be very high. Detailing. Beam element, section properties, material properties, design codes. Factor. The shear stress due to the shear force and torsion together exceeds maximum allowable limit, because this may fail in shear and torsional. It is not able to resist the torque. Okay, so this and in this one go to detail. Go to 150. Reinforcing requirement exceeds the maximum allowable limit. Okay, so go to concrete, go to verify all concrete frame failed. The design check. Do you want to select them and click right and show selected object only. Now These are the three member that is fail. But why? It will go to shear stress due to shear force and the torsion exists maximum allowable limit. Close. Okay. So now I will close this stream online. Okay. Thank you for watching. Now this time for slope save change.